Hi, today I'll be discussing on the analysis of variance, important statistical measure abbreviated as ANOVA, ANOVA, which is an extremely useful technique concerning researchers in the field of economics, biology, education, psychology, sociology, business, in industries, in several other disciplines. This technique is used when multiple sample cases are involved. As stated earlier, the significance of the difference between the means of two samples can be judged through either Z-test or the t-test, but the difficulty arises when we happen to examine the significance of the difference amongst more than two sample means at the same time. The Anova technique enables us to perform this simultaneous test and as such is considered to be an important tool of analysis in the hands of a researcher. Using this technique, one can draw inferences about whether the samples have been drawn from populations having the same mean. The Anova technique is important in the context of all those situations where we want to compare more than two populations, such as in comparing the yield of crop from several varieties of seeds. The gasoline mileage of 4 automobiles, the smoking habits of 5 groups of university students, so on. In such circumstances, one generally does not want to consider all possible combinations of two populations at a time. For that, we require a great number of tests before we would be able to arrive at a decision. This would also consume lot of time and money, and even then certain relationships may be left unidentified. Therefore, one quite often utilizes the Anova technique and through it investigates the differences among the means of all the populations simultaneously. The essence of ANOVA is that the total amount of variation in a set of data is broken down into two types. That amount which can be attributed to chance and that amount which can be attributed to specified causes. There may be variation between samples and also within the sample items. ANOVA consists in splitting the variance for analytical purposes. Hence, it is a method of analyzing the variance to which a response is subject into its various components, corresponding to various sources of variation. Through this technique, one can explain whether various varieties of seeds or fertilizers differ significantly so that a policy decision could be taken accordingly concerning a particular variety in the context of agriculture researchers. Similarly, the difference in various types of feed prepared for a particular class of animal or various types of drugs manufactured for curing a specific disease may be studied and judged to be significant or not. Through the application of Anova Technique. Likewise, a manager of a big organization can analyze the performance of various salesmen of his concern in order to know whether the employee's performance differs significantly. Anova Technique in general investigate any number of factors which are hypothesized or said to influence the dependent variable. One may as well investigate the differences among various categories within each of these factors, which may have a large number of possible values. If we take only one factor and investigate the differences among its various categories having numerous possible values, we are said to use one-way ANOVA, and in case we investigate two factors at the same time, then we use two-way ANOVA. In a two or more way ANOVA, the interaction, if any, between two independent variables affecting a dependent variable can also be studied for better decisions. What is the basic principle of ANOVA? The basic principle of ANOVA is to test for differences among the means of the populations by examining the amount of variation within each of these samples relative to the amount of variation between the samples. In terms of variation within the given population, it is assumed that the values of X differ from the mean of this population only because of random effect. That is, there are influences on X variable which are unexplainable, whereas in examining the differences between populations, we assume that the difference between the mean of the jth population and the grand mean is attributable to what is called a specific factor, or what is technically described as treatment effect. Thus, while using ANOVA, we assume that each of the sample is drawn from a normal population and that each of being tested or effectively controlled. This, in other words, means that we assume the absence of many factors that might affect our conclusions concerning the factors to be studied. We have to make two estimates of population variance, usually one based on between samples variance and other based on within samples variance. The two estimates of the population variance compared with the F test, where we may work out like this, where F is equals to estimate of population variance based on between samples variance divided by estimate of population variance based on within samples variance. This value of F is to be compared to the F limit for given degree of freedom. If the F value what we have worked out is equal or exceeds the F limit value, we may say that there are significant differences between the sample means. For F limit value, we have to refer the F table values. Based on that, we can identify whether there is a significant difference between the sample means or not. So this is the statistical measure analysis of the variance, which is also called as Anova, one of the important statistical measure. So we'll be discussing one-way Anova or two-way Anova in the next session. Thank you.